Okay, so we are back after a short break. And yeah, now we have a session, point cloud to CAD conversion. And in this part of our event, we will have also two sessions. In the first session, we will produce accurate floor plans using ARES Commander and Undet tools. And in our second part, we will show you how to set everything for elevations and sections creation. Of course, there's not enough time to show everything, but Darius, my colleague from our drafter team, will try to show which tools he's using for vectorization process. And during this workshop, we will use ARES Commander 2024, and that plugin for ARES, and that browser, sample point cloud, and some sample DVG files. And all partitions we will share these files after this event, probably tomorrow, and you will be able to practice yourself. Of course, if you have your own point cloud, you will receive installation files. You can very easily create a project and bring the point cloud into ARES Commander. As you know, all projects start from the task and baseline information. So it's the same project with this. So typical what our drafter is receiving from us, we are receiving some short brief of the requirements. What we need to do with this point cloud. For example, for this object, we will talk about the floor plan creation, elevation, sections. So in this task, as you can see, next to the building surveys, there's a floor plans requirement and listed all the objects which we need to vectorize, what type of levels, annotation we should apply to the drawing. The same with elevations. Yeah, we need to have a scheme or just to write what type of elevations we should provide. And the same with the sections. Problem with the sections, but sometimes we don't have information about inside. And we're just sending floor plans once we finish to the end user to just draw the section lines and where we need to vectorize that. And the main thing which we need to tell to our drafters, the survey scale, the accuracy. So in this case, we have a survey scale of 1 to 100. And the final drawing should be delivered in DVG file format and PDF files. And sometimes we have the blueprints of the old buildings, which we are scanning using laser scanners. But all these blueprints is perfect to estimate, to calculate the scope of work for laser scanning, maybe for vectorization. But during the vectorization stage, we are not using these drawings, and we are using point cloud as a guide. And now I will give the word to Darius. And Darius, do you hear us?
Yes, hello everybody.
Yeah, so Darius, I will make you host and you're able to share your screen and show some workflow, how to vectorize a point cloud into 2D drawings. So once again, Darius is our CAD drafter. Okay, Darius.
Okay, hello again, everybody. And we have to show how to make a CAD drawing from point cloud. From now, we start doing floor plan from existing building. So let's start from new file and choose a template to work on. So we have a file with layers, all the settings, and scale and so on. So let's open its empty file. I erase unnecessary things and open that point cloud on which we will work. Is building, existing building, and we will see that it has many positions. All of them are grouped, as you can see by level. We can switch off any of it and leave some of them. So let's do a little part of this building, for example, a ground part. So first of all, this is the deactivated point cloud. It's full building. As you can see, you can rotate it. It's just big and full, but we will take care on ground floor. So let's clip one small part, and to work better, I prefer to do 2 viewports from which I can see a top of a building and the front or left side. Okay, I need to, well, I have 2 viewports. I can resize a little bit. That one is a reference, another one I'll be working on. So from this point I see top, so I'll do floor plan, and from this point I see a front view, so I can clip a needed area. I'll be drawing ground floor, so switch on bubbles. Bubbles are scan positions to see on which level is the ground floor. This is it. So the floor is, as you can see, more dense point cloud. That here's somewhere this floor. I will cut. I'll make a section cut on like 1.5 meter around the building, and now I see accurate floor plan, but it's still not vectorized. I need to vectorize. So first of all, I find a long wall and draw a direction of it to catch the angle from one corner to another. For this is for making UCS. In AutoCAD it's called UCS, but it's CCS. I don't know how it's correctly named, but still we have to choose right direction of axis. Then when we choose, we can name it and save it. CCS style. This unnamed, let's name it as plan 1, and it will be saved. We can use it later to draw lines by ortho. So activate view by active UCS, and now we have a rotated floor plan. So let's make walls. I did one line, so I can make another ones. First of all, the plan, the workflow would be like, I will create wall lines. After next step, I'll create openings, doors, windows, what is between walls, between wall lines. Another step will be, I'll be working on a lower part of floor plan. It means floor and all the objects below section line, this section line. And another step will be ceiling view. I'll fill ceiling view. So now I'll draw walls, simple lines, just to using our ECS. Well, sometimes it's out of, but it's not new construction building, so nothing it happens. there will be no many lines by ortho, but I'll draw. I will try to make them perpendicular each to other, to put not to have troubles with the opening, with the doors and windows, to make it parallel. So some of them are copied, some of them drawn by polyline command. Out of accuracy, let's try to change corner. Also, we can switch perpendicular snap, see if it works. If not, then okay, let's use our corner and let's try to make it parallel each to other. Well, what do we have? Still need more walls. Let's do. We can use not only polylines. We'll draw by rectangular. I'm not currently not trimming. I'll trim later when my part will be done. I'll do it by one. Okay, few walls left, and there's longer path from corner to corner. Yes, it's good. Let's copy. There's some situation. Let's copy also and have this part. Also, external part should be also parallel. This will go to external walls layer, and okay, let's see, what do we have? We have some lines, but now we have to trim corners. We can use chamfer command, I guess, but also we can simply trim. Press trim and double click whatever you like, enter or space, and simply trim unnecessary line ends. It's like a chamfer, but when you chamfer, I guess it's joins into a single line. So if you don't want to have a single line, you just simply trim and you will have separate polylines. Okay. I forgot the situation. I will have there's a corner perpendicular. Okay, it's not big fail. Well, that's needed, I think. That's one by one we have drawn a little part of that building, a few rooms we have now. We have some strange situation, but let's do it like, I guess it's door and a wall. So now we will have walls by cut line, vectorized. As you can see, there are polylines. So as you see, we use point cloud as a background for drawing. And now the first step is done. Another step is to do openings. So we can use our existing tools in ARES for floor plans. We have created doors or windows or whatever. So let's try to make door with opening. In here, let's take another corner, this one, opposite corner, and put doors in here. Okay, it's a block, so you can flip it or make it the way you like. Later on, you will burst or explode it. There is also door Let's do it. One corner, opposite corner, and point. Okay, let's flip it. So this is how fast you can make openings, doors. Here we have windows. Let's try window with opening tool. Let's take one corner and opposite this one corner approximately here and put point where windows will appear. It's in here. We can only adjust its place and thickness by moving arrow, whatever size you like. But as you can see, it's double window, so we can make a copy of it, of its block, and adjust. Okay, and fill with the lines or walls. I guess it's note. No, it's okay. It's okay. Everything is okay. So this is how easy you can do using blocks. Just trim unnecessary lines, and you see it's almost done window. I guess it has to be the same as here, typical. So let's copy it, move it to this corner. I think it will fit more or less, yes. We can trim unnecessary wall lines because there will be seal. How to find it? Okay, let's find other objects beside cut plane. So here we have one view section. Let's call it plan. This is the one we are using now. Let's duplicate and create another, and we'll name it floor. Now we can adjust view section to the lowest placed, and it shows the floor. Okay, let's duplicate the same to the ceiling. Later we will use it. Ceiling. It's the same, but the only thing, I will deactivate the whole point cloud and switch off whole first floor because I'm on the ground. I don't need floors of first floor. I switch off. Again, turn on ceiling view section and move on to the top to catch the ceiling top area. Yes. So let's use floor. From that coloring, we don't see no differences in height, but when we put on plane, coloring by plane, we see different colors. So you can switch to any palette you like. You can choose any distance you like to see. 2 centimeters difference in colors, 3 I think is enough. And you see those rooms are in the same, those room floors are on the same level, this lower or higher, we will see later. So let's make a cut in this view section. I wanted to draw window sills. Let's take less of floor. Okay. Now I took window sills. If you're not okay, I guess it's the same direction as the wall. So let's copy a wall. Let's move to Windows layer. I can switch off extend that line, see if it fits. It's all right, it fits. Just draw the ends. Okay, switch the layer, the windows. End lines, one line, another line. Trim what is between. I can use fillet command because it's a little bit curved. 25. Let's make radius of 0.5. What would be fillet? No, it's not working. Too big a radius, I guess. 0.5, not 5 meters, but 5 centimeters. Yes, now it worked. Okay, window sill and external window sill. It's somewhere here and another part of window elevation. Here we have first step done. So let's move to the floor and draw these small steps. And what do we see on the floor? All the objects. It's not fully loaded point cloud, so let's make small view section to see it deeper. Let's change layer to change in floor, and we can draw those floor changes. Yes, has to be this step by this line, I think. Switch off things. Yeah, just finish. Almost done. What else is left? Let's see. Full point cloud. Here's something that way. Let's make deeper look. It's not somewhere else. So it has also step. Yeah, it's done. Here is something, but if you have doubts, let's go to browser. Let's switch our ground positions. Let's go to this, press double click on that bubble, and Undet browser starts exactly in this position. So we see this door here, and that is our change. Yes. So we can draw change in floor here and there. I simply copy it to keep direction. Like this. Now it's that part is also done. Let's go to ceiling view. Ceiling has more, is more colorful because it has more changes in height. Let's make it a little bit bigger to catch between doors. Yes, we cut. It's almost flat, but here is not flat because it has, as we remember, difference between planes 3 centimeters. So 3. So 3, 6, 9, 12 centimeters difference in here. And here also between doors. Let's do drafts. Here it's same direction as well. I think it's soffit. If I have doubts, I go to my scan data. Yes, it's soffit, right? Pick right polyline to copy. So soffit here. I think soffit here. So as we remember, here was soffits. It's and that also. Okay, so we have done all 3 steps. We drawn walls, openings, what's on the floor, what's on the ceiling. There's not much objects, but now we can try to annotate levels of that object. Let's switch to floors and try to annotate floors using our tools. Here we have many annotation tools. One of them is FL, a floor annotation. But first of all, let's press on snapping node that it would snap to point cloud, and then press annotate FL. It catches point cloud point and snaps to it. Now it is that we can also copy to another with insert point. Here it is, and snap to that room. That, well, this is the same. You will feel no difference, but here and here it's different. It snaps and writes immediately. Same with ceiling. We have ceiling annotations and many others, but same ceiling. Here it's snapped. Let's make a copy with insert point and put here whenever it has changes. It's interesting to see from here to here if it's lowers and what is the direction. So it goes that way. Let's mark. Also to annotate doors and sills and windows and other things, not levels, but differences between heights. We can use Undet browser and scripts that Mario shown before. So, for example, let's try to annotate this internal soffit. Let's go to this scan position and turn on this tool, activate script, and find out soffit level, SOH, soffit level. Here it is. Pick a point of a soffit and the floor, and it calculates the difference. So now it has to appear, but well, it has to catch point. Now it's appeared. So 255. If you don't believe, we can check if it's true. Measure by simple tool or by distance. Okay, here we have. Let's see from left side. Here's the floor and here's our soffit. 235 has to be, well, almost, because I picked wrong floor. But if I'll pick this, it will be 230. It's not a problem. Let's pick. And now it appears 230. You need just to check yourself to avoid those mistakes. Let's try to do it same with window. Choose a window annotation. Float to window sill, sill to head. Okay, we can choose points of head of sill. Make sure that it catches point, it caught, and floor point. Yes, it appears. Maybe I chose wrong. It hasn't B minus, but it's still.
Yeah, so there's when you're using a scripts, you just need to read how the script is written, because all the script was written by me. And for example, now if using the script and written floor to window sill, so first click should be on the floors, later on the window sill, sill to head. So first click floors, sill, head, and you will get annotation of this window. Yeah.
Okay.
If you will, because for the first time you clicked, you just click on your Windows head, not on the floors. So now it is why you have a minus distance.
Okay, I can try floor, sill, sill, once again sill, and head. And does it appear? Has to be again.
Yeah.
Floor.
Now it's appeared. Yeah, because sometimes when you're receiving a message in Undet browser, you just delete, because when you're trying to pick a point in Undet browser, sometimes you're receiving a message that point cloud point is not found in that, and it means there will some reflections of a point in inaccuracy, and the software is not allowing to take the dimension of that point. Yeah, and for example, if a script is from the 3 steps and you skip one step, it will take a bad dimension. Yeah, so just need to check when you're clicking in the browser if and that is read the level of that point.
So you can use that annotation tools very easily and fast, as Marius shown before, and it writes immediately. So for example, these are stairs, as you can see. Yeah, it is snapped exactly to the point cloud and writes the right level. So that is easier to work. Okay.
I think that's all that we need to know about the workflow for the floor plans, because as you can see, there is vectorize the main outlines of the buildings, of course, only the small part of the drawing, because it's a huge building, but the process is the same. Typical, we are just slicing the point cloud, and the first we are extracting the walls, internal, external walls. Later on, we are filling the drawing with the objects which are visible in the floor view, later on in the ceiling view, inserting doors, windows, other type of blocks, and later on, if the customer is asking, we are placing the annotations. And what type of annotation should be inserted in the drawings? Levels, heights, so it depends from the task which drafters usually receiving with the point cloud. Yeah, so in this case, we showed a little bit both annotation process. Maybe you can show one more script, for example, how to annotate the room height and floor levels with the 2 clicks.
Yeah, let's try to
using Undet browser. Yeah, so
let's pick a,
because in Undet browser you will find 50 plus scripts to annotate your drawing, so you can just
you just need to find it. Floor level room height, and room name. So let's pick and just pick floor and ceiling. Just catch the point. And ceiling. Now it appears.
Now,
See,
yeah. So if your object, yeah, and now the software showing the floor levels and the room height, and you saw that Darius just tried to pick the point, and the software just showing that point is not found. Yes, it happens. It's a real project, so it's not perfect demo example, and there is some reflections. So it's working as should work in every project, yeah, because when you're doing the scanning, we're scanning the object with everything inside. It's not an empty houses, rooms, buildings, and there can be a lot of stuff. Okay, Darius, I see that you're using most of ARES Commander features from the command line, not from user interface. So one question from you, it was easy to you switch from AutoCAD to ARES Commander?
Partly yes. Few features I missed from, but for 2D drawings, it's perfect. I mean, it loads point cloud bigger with more points. It's not streaking. The only problems I had with the 3D modeling, because I'm not used to for that tools. They are the same, but I miss some UCS by face when I 3D modeling. Maybe it exists, I don't know. I have to learn more. And I miss also when I pick one phase of solid and I can extrude it. So that's the only thing I miss. But
you're talking about 3D modeling, yeah.
Yeah.
But if you're talking about point cloud, you can for 2D drawings. So as I saw from this video, just typing the commands from a command line, leaving the lines, copying, and producing the floor plans. And one more question before we will go for the elevation section workflow. I'm receiving a lot of questions how to organize the drawings. For example, in this tax, in this project, you have a ground floor, first floor, second floor, third floor. And when you're doing the vectorization, how are you organizing the drawings? So each drawing for each floor, or you're trying to vectorize everything on the same file?
Yeah.
Splitting the ground floor, moving all the CAD lines to site and vectorizing on top. How are you organizing these drawings?
Some of the drafters are used to have master drawing. When they have one file, they open and have all the floors copied in one line. So first, second, and others. In here, there's no way to have it because point cloud has coordinates and it's exactly in the same place, the first and the ground floors. So we do one floor level, like drawing. We save it and pick another file, do another floor level, save and pick another file. So we have multiple files of drawings. Also, they can be annotated using that tools easily. And after that, everything is burst, exploded, and you can only after that copy everything into one file if you want, but it's not necessary. We work on separate files. That's the way we do.
And the last thing, because we developed in that browser only a couple years ago, maybe. And now, what do you think about Undet browser? It's helping you to understand the situation when you're doing vectorization?
Yes.
Or as you saw a lot of point clouds in your life, you don't need to have Undet browser anymore because all the citations are clear for you.
No, there could be rooms with many trashes and rubbish, so you can't see from real point cloud what's happening, and you go to that position and see. That's the one reason. Another reason, just to not to waste time by cropping point cloud every time. You just go to that room and see that there is nothing on that wall, nothing on that wall, and you expect that there will be those radiators and window and some of few lines here, nothing more. And you go to another room and analyze. Oh, there will be difficult ceiling, it needs more time, but nothing on the floor. So you analyze very fast, and also helps to understand the situation, and helps also with those tools, with the script, with the translate view section here, and other tools for 3D modeling. I won't tell you.
Okay, Darius. So for this part, I think it's enough just to understand the basics, how to vectorize for floor plans. So if you will have some questions for Darius, you can ask. Maybe we will answer later on. And of course, if you want to have a live demonstration, how to do that, please contact me. And Cedric from the Grabber company is telling for 3D modeling, you can use dynamic CCS command to select the face and extrude. So where is this tool? Yeah, yeah, but as Martina's told, we're using different softwares, and Darius is more responsible for CAD vectorization and 3D modeling in Revit. Yeah, and so lately he don't do a lot of 3D modeling in ARES Commander. Okay, so let's go to the second part and to show us how to start vectorize the elevations. Yeah.
Yes, so we start from the same. We have template, a clear file with the layers and all the information we need. Open project, our point cloud, and let's find where is that elevation could be. Okay, active UCS. I guess it's not switched to wireframe mode.
CCS and view control and 3D wireframe.
Yes, that's exactly.
So one quick topic, one thing, that if you are working in the 2D environment, 2D wireframe and ARES Commander, the point cloud will disappear.
Yes.
Yeah, so because we need to have a graphic accelerator activated, and it's working only on 3D wireframes. So don't forget to activate shaded view or other flat visual styles. Yeah.
Okay, so if we do elevation, I guess we don't need internal positions, so I'll switch off it and leave only external positions. And we have many planes to do, but let's do one of them. So similar as before, we need to pick direction, right direction. I'll just switch off node, not to snap to point cloud. I draw from corner to corner to catch the wall direction.
One thing that is, and now you just activated the snapping to a point cloud points, and when I'm talking to the customers, we always asking if it's better to snap to a point cloud or not. For example, you're doing a lot of point cloud to CAD projects, and you're snapping to a point cloud or not?
Only when you use special blocks to snap, only in that way. When drawing, I use only UCS to have all the lines at the same elevation, because from the top it's on the same, but when you switch to the front, it could fly here and here and here and here and here.
Mm-hmm.
It's not good looking.
So you are recommending not to snap when doing the floor plan vectorization,
yes.
or elevation vectorization, yeah.
Yes.
You can make mistakes, yeah.
So I did direction line, and I can do our UCS. I need to do it in that way that the Z-axis will look at me forward. So it's simple. I a little bit rotate just to show you. Pick one point, another corner, and a top. Now Z is looking at me. Now it's good. Let's name that as elevation 1, and it will be saved. And we can use it, activate it. Let's switch to 2 viewports. One will be front view, another view from a top. Later you will see why I'm doing this. Activate full point cloud and clip our part. This beautiful part. Yes. And here, let's switch to the top to control the depth of our point cloud. Now it's through all building. I need only one front plane here. And we will change coloring later on. A small part of building. Let's change the coloring by plane to see the difference between planes. Pick a plane, distance, it's okay. Now we have small part. Let's do first external profiles, and then we go to inside of elevation. So to load point cloud points more, let's reduce our view section, and now it's loaded more points. Let's make a profile. One profile on one side, and later on we will try to mirror it. Well, you see, it's not catch, but it's not a problem. I think it's not that, but somehow like that. Later on we will check. Everything is drawn in our UTS in right elevation. So here and just profile. Let's see, it's good. On the other side, it has to be the same theoretically, but practically we will see when we will make a mirror. Let's load more points and mirror that profile using ortho. Yes, mirror and pick in the right place and see if it's good. Here we have to see more of point cloud just to compare if it's good. It's not, but it's not problem. We can split that profile at one point and have another line. Simply move, trim unnecessary, go down, see if it's good. It's not really fits, but same tool, split at point, move and have it. Just trim unnecessary. Yes, now you have two profiles, and we can just close it on the upper part and on the lower part. Pick a roof layer. I'll do approximately now, but when you're working, you need to check the upper line. Now it's only demonstration. And close that profile, two profiles between each other. Simply. And on the lower side, I think there was stairs. This is the upper stair line. Let's draw it to make closed polygon. I just trim unnecessary things. And now we have like envelope of that elevation. So we could feel what's inside. Here is some part. It looks like roof. We can use orbit to see in 3D. Well, it's something like roof. Let's activate our ECS and draw it approximately upper side and lower side. Trim unnecessary. What do we have? So we will have to draw this part. Let's do fast. I will use rectangular and later we'll offset it from here to between yellow and green. Like this. Let's offset. Opa. Trim unnecessary. This also I think is necessary. Just extend to the roof. Not too much. Okay, what do we have? This big rectangular, and also we have 3 rectangulars. I think the same. So we can draw one and copy. I need to extend and trim this one. We can have this line also. And after that, we will copy it in here. You see, we have here 2 lines. Here is missing, but no problem. We can mirror it. It's not mirrored. Once again. No. And another rectangular in here. Well, let's make one another time. So I have 3 rectangles. What's inside there? I guess windows. We need to do few windows and copy it. Let's go deeper to see windows. Now it appears.
Yeah, so probably one tip when you're working with televisions, don't forget to copy, mirror, stretch, because usually there's a lot of the same objects on the buildings.
Yeah, it's almost the same everywhere. Just a few. Depends on accuracy. Well, those windows are the same, and this is different, slightly different. Also, let's copy the
And
upper one.
talking about the accuracy, as Martinez told, when you need to prepare high detail drawings, So you need to spend more time because each Windows doors can be a little bit different. And then you have high details requirements. So you need to show everything as it is, and you're spending a lot of more time. Then you have typical detail like survey 1 to 100. You can copy a lot of objects and accomplish the drawing much faster.
So we have 3 windows. For example, here we don't see the lower part of window, but there are a few ways to see it. We have scan data from drone. It's a little bit rough, but we can see the upper part. And also we can see from internal scan data on that floor, but not usually. So approximately it's here, this line, the end line. That's sometimes it's helpful. And we have 1 line of windows. So just copy it using our reference points. Let's use a midpoint of that big rectangular. I think it will be the same. Later on, we will check one and another. So we have, yeah, it fits good, all the windows. Like half of work is done. Same with lower part. You see those 3 doors. You may make one, copy it. Just don't waste time.
And there's one question. Why are you using coloring by plane mode? Because we have a coloring by intensity, by true colors, yeah, black and white. No.
Yeah.
But why using coloring by plane? Yeah.
It's to understand faster where the plane is changing. For example, here we can see pink, blue, orange. Those are different planes. When I color by intensity, also I can see, but from zoom out, I cannot see. Well, only zooming in. By plane, I see it just in 1 second. Like I understand the whole structure. For elevation, it's very fast and useful to understand. So simply you can copy parts or copy the whole profile. I'll copy a few parts and generate 1 door. Okay, we have.
So when I just started to work with laser scanning, I don't know, more than 10 years ago, all this coloring by plane was look like a rainbow, and it was hard to understand. And now when working more and more with vectorization modeling, you see that the coloring mode by plane is the best one. And even for our customers, which are asking if we should take laser scanning with true colors, it means to spend more time in field to do the scanning and later on take your photos with the scanner. It could take twice much time. And I'm telling why, because you will not use that colors if you only need just to produce 2D drawings. You don't need that colors. You can color by plane. Of course, when customers asking to deliver point cloud, so you can ask if you want to have a true colors, but for vectorization process, as you can see, we don't use any coloring mode apart with coloring by plane. And then that you can set the fixed size interval and just get the clear view of elevations. Okay, that's so I think for the elevation workflow is clear for us. Maybe you can say some tips, what you want to say, but the main process, what I saw from your video, that first task is to vectorize the main outline of the building, yeah? And later on, what later on? You are just going inside to show windows, doors?
Yeah, like from bigger parts to smaller parts. From big masses to small masses, like from big planes to smaller details and smaller, and later on detailizing doors, window streams, and so on. Don't start from small things to do big things and small things later.
Exactly. When you starting with elevation drawing, don't draw the doors or windows at the beginning. First of all, just draw the outline of the buildings, main outlines. Later on, you will find the windows, doors, and you can vectorize that. And some users making one mistake, which is at the beginning seems that it's how to say it's like a joke, but we're just vectorizing the outline of the building, and later on we need to go deeper to show windows, doors. And for example, if we just started to vectorize from the ground floor, we're going up to show the roof details, and we are trying to vectorize the windows frame of the upper floor. And usually that part of a building has the lowest density because we're doing the scanning from the ground, and the highest density scans represents the objects which are not far away from the scanner. So first of all, just slice the point cloud to see entire view of your building and pick the nice looking windows which will be scanned very detailed, usually from the first ground floor, and later on you can just copy to the upper floors. And don't do opposite, because you will spend a lot of time to vectorize the window, and later on when you will start to copy that windows, you will find some mistakes.
While you were talking, I did all 3 doors simply by copying and mirroring. Later on I will need to check accuracy, but well, it has to be the same.
Yeah, sometimes, as Martinas told, sometimes it's psychological hard not to show the deformations, yeah? And if you will start to show all the deformations, so it could be bad. Even I have one joke, because at the beginning, when you just started to work in this company and do a lot of CAD drawings from a point clouds, and we bought a new scanner which scanned in maximum details, and we just started to vectorize and show all the smallest details, and I just happy delivering drawings to architects. Architects opens in DVG file and asking why it's not a straight lines. Your hand is shaking, was shaking while vectorizing this floor plan. Yeah, so don't go with the deformations, because the scanner technology provides one-on-one copy of digital, of physical objects, and you can bring that copy inside your computer. And if you use traditional methods, ruler, distometer, so you're just taking some measurements, but you don't think that everything is deformated. And we received some questions, so that was maybe, yeah, so maybe I will answer that questions and we'll go to the section view workflow. So Isabella telling that now she can work much faster using Undet and ARES Commander, especially with easy commands such as below power trim. Yeah, it's a cool feature of power trim, and you can select multiple lines at once. And we received one more question. how to save station names from a structured E57 in that project. Yeah, so when you're creating that project, you can import structured point clouds, and each file will have a name. Yeah, so, and once you will create this project with your structured point clouds, in the scan data manager with Darius, could you expand the external group scans?
Yes. Let's I deactivated because.
Yeah, and as you can see, just expand one group of external scans.
Yeah.
And just look that all the scan station name are listed here, and you can deactivate, rename that names, but what files you will import, you will find in the scan data windows, because they told one and that benefit that we offering live data structure. So if all the files are not merged together, then you can manage the visibility of each group or individual files. And even with Darius what showed for us, for example, if you're working with the elevation view, you need to deactivate internal scans because there's some reflections.
So I can switch to section view.
I have one question Richard asking, which is related with elevation workflow and the floor plan workflow. And he's asking, when you're drawing the elevation, as we are being shown, do you check what all the windows line through the plans? Yeah, so there's two workflows. Sometimes customer is asking to match drawings of elevations with floor plans. In this way, we are xrefing plan view to the elevation drawing and extending the windows lines, and later on just vectorizing that. But what is the problem? The problem is that you will have like 3D accuracy, and you will spend a lot of time to do this type of jobs if you want to match everything: sections, floor plans, elevations, and sometimes it's not worth to do that. So for example, in this case, if a survey scale is 1 to 100, so it means it allowed tolerance is around 2 centimeters. Yeah, so in 2 centimeters, your windows in elevation view can not match in the floor plan view. Okay, so usually we're doing such type of works. As I told, when you want to match everything, you're doing like 3D modeling, but using 2D tools. So maybe you should go with 3D modeling and later on extract the drawings from that 3D model if you need such accuracy. Because in the CAD applications, to do this process, it will take a lot of much more time. And if usually architects using elevations and sections just for the levels, not for the geometry itself. Yeah, okay, Darius. So sorry interrupting you, but when I'm receiving some questions, I must answer that because we're doing this webinar for you guys. So feel free to ask if you have some questions. And now, just in short, explain us how to produce the sections.
Okay, so
building.
If you have a full point cloud and you have decided where the section line will go, so using this section line, you can create VCS, and that will look forward at you. So it means that way. And I created UCS later on the same procedures. Let's name it to save it. Section 1, for example, it will be also same, create 2 viewports, one bigger, one smaller, one for section view, another for top view of section view. So we have this type of axis. Let's clip our point cloud by line, by this section line, and see what we have. Let's make it thinner to have only section play lines. So here it is, almost done section. Only thing is needed, we need to vectorize it, as you can see. So first of all, when I produce sections, I do these steps. I do these section lines, and later on, if it's required by customer, I go deeper forward view if it's needed. So before doing, I ask if it's needed, not to waste time. So simply repeat the point cloud as in elevation. Create, copy, and mirror. Just a few comments you will use very often, like always. You will be using copy, mirror, and move, maybe trim, but it's easy to learn. Just a few comments and you are.
And I see that you're using only from the command line, and it's very cool because
when I started, it was not that.
Because when you have an experience from AutoCAD with the line work, so in ARES, the commands working the same, shortcuts the same. So if you are just working from the command line, so you can start using ARES Commander in seconds, because you don't need to check what icon to click. You're just writing. You need to line copy to shift, stretch, just a couple of clicks, and that's all. And one tip, when I was responsible for organize the modeling task and vectorization process, I can say that drafters which are using command line instead of interface, we are working at least 30% faster. So now if you are vectorizing and picking tools from the user interface, just spend some time to understand the shortcuts of tools, and you will increase your productivity 20–30%, even sometimes more. And you can see Darius even don't think where you need to find the command. You just know what he wants to do, just typing and doing instantly. And each mouse click moving up and down, it's taking time. And time is money, yeah. Yeah, so if you have some questions, please ask Darius while it's on, because it's a couple of minutes and we'll end our workshop. Yeah, so it was a long event, but we're doing everything for you guys. So we are recording this session, and later on we will place this records in our YouTube channel. All the attenders, we will send letters with installation files to test ARES Commander, and that by yourself. Even we will share this point cloud project with you to test the same workflow what Darius is showing now. And yeah, if you thinking to switch or just looking for the software, please contact me. I will always be ready to help you of using the solution. And as you can see, Darius will finish this section where I'm talking, but as you can see, using the same coloring mode by plane, because it's representing the geometry changes. Yeah, because the color can be the same for entire building, but coloring by plane showing a different geometry, and you can very easy to understand what to vectorize. what else? I don't know even what to say about the vectorization process, and that Darius told that it's very similar like vectorization of elevation.
Yes.
Yeah, because at the first you need to vectorize the section line of a point cloud. To create a section line, you can use clipping box tools. When you have a section line, you're just using ARES tools to vectorize point cloud. As you can see, it's working perfect. Copying, modifying line work, and completing this job. Okay, so maybe you can tell some tips about the section vectorizations, but
nothing special here. Is same as elevation. Use coloring by plane to understand differences in planes.
Maybe can you activate the point cloud slice and go to the upper floors to show some areas which are not scanned from the ground?
Let's try to find those places in section line.
Yeah, probably will be next to the windows. Yeah, for example, this. Yeah, just
switch to the windows. Yeah. And I need to.
Yeah, just zoom the windows sill from the external. As you can see, sometimes where is no points. Yeah, because when we're doing the scanning, from the ground, as Martinez showed us. And if you want, you can combine terrestrial laser scanner and photogrammetry. And Darius, let's try to activate the roof scan position. And now you see that you can clearly identify window sill. If you, in this case, if you don't have such data set, you will not able to vectorize these areas. And sometimes, even when Darius is doing the vectorization, the areas which we just, let's say, vectorizing without the point cloud, we are marking in the red, just to tell the customer that was not reachable, because there are some areas where drone flight is not allowed here. But if you have a possibility to use laser scanning and drone together, you can easily import the same point cloud files from the drone and laser scanner in the same and that point cloud project all together, manage visibility and activate. Even I was told that drone data is rough, so it's not looking perfectly nice compared to laser scanner data. But when you need to receive such information, you can always use the photogrammetry point clouds to have these slices.
Same with internal positions.
Yeah.
You can't see from ground level what's from the top. So we can, some lines we can assume and mark in different color, or maybe dashed line. But yes, it's the same, similar. Now we don't see here no points, but we can assume that it goes like that. Just mark that it's assumed.
Yeah, because when you will deliver the drawing to end users, we will have only the drawings, so we don't know how you created these drawings. So if some areas was not clear for you, it's better not to lie to a customer and just mark these areas. But it's better to take some measurements in place if these areas are critical. But usually when you're doing the scanning, you're capturing everything what you need, and so, some small areas, if it's not captured, are not required. For example, the same with the roof. Yeah, from laser scanner you don't see. If you don't have access to the roof, you can only use the drone mapping. Okay, so thank you everyone for joining the session for us. I see there's still a lot of people watching our workshop till the end. It's a lot of information. As I told, it will be a record. and the was not able to watch everything at once, you were able to watch videos anytime from your home. We will maybe split into a part for even easier navigation. So again, thank you, Luis, for joining the session, showing history of ARES Commander, Grabber company. Yeah, you see that it's a really cool software. And again, Darius, thank you very much for your time, showing how to vectorize the sections, floor plans. I see Martinez is not here, but thank you, Martinez, as well, for showing his experience of reality capture projects. And again, thank you for everyone joining the session, and see you on the next video, maybe after 1 month.